Well, good morning. So welcome to another semester. It's going to be interesting. So the name of this class is Instrumental Analysis, and I will be your teacher. My name is Jean Win, and my Chinese name is Wen Jing. And as you can probably see, I am not Chinese. I'm actually an American, and I got my PhD in America, but I have actually lived in China for the last 20 years. Although currently, like many of you, I am not in China, I'm actually in America. So it's 6:30 in the evening for me. So I know a lot of you are in different places, so it's going to be interesting. So if you want to address me by name, it's actually okay to call me Jean, which is my first name. I know you don't normally call your teachers by your first name, but if you want to call me Jean, that's fine, or Dr. Jean. The doctor is because I have a PhD, and my PhD is actually in analytical chemistry, which I got here in America. Oh, okay. Some of you can't hear. Let me try adjusting my microphone up a little bit. Okay, can you hear me now? Can you guys hear me now?
I can hear you clearly.
Okay, all right. All right, so let me start over because maybe you missed the beginning. So I was just introducing myself. My name is Jean Win. I'm an American, but I have been living in China for the last 20 years, where I have been a teacher for the chemistry department. And right now, I'm actually not in China. Like many of you, I'm in America. So I will be teaching this from America while you guys are in different countries. All right, so that's a little bit about myself. All right, so first, I just want to talk a little bit about the course and some things that were in the syllabus. So let me go ahead and go through that. So obviously the class is going to be online. We all know this is not ideal. It's hard for me to teach this way. It's hard for you to learn this way. I know that, but we cannot change that. So we're just going to have to do our best and adapt and be flexible. And we'll be using a lot of different platforms. Primarily, we'll use Zoom for the classes. I am recording this, so you can always watch the lecture again, or if you can't watch it live, you'll be able to do that. We have a class WeChat group that we can use for communication. We'll have a Baidu Cloud and Dropbox to use to pass materials. You can always use email to contact me. And then Rain Classroom, you can use online for that. So there's still some students say they're not hearing. You might want to check make sure your sound's on your own computer, because from my end, everything should be okay. So I don't know what to adjust so that you can hear me. You know, I've used Zoom a lot and my microphone's on, my speaker's ready. So if you're not hearing me, you might have to wait and watch the recording later. So a couple students have raised their hands. So yes, Barry, and you don't have your name, Galaxy. You can turn your mic on and talk to me if you want.
I am hearing you, Lao Shi.
Okay.
I can hear you.
All right, good. Can others hear me?
Yes, Laushi.
Yes, Laushu, we can hear you.
Okay, so I'm going to go ahead and go on then. Okay, so we're starting off kind of chaotic. Let me just type a chat. So, and okay, all right, so let's go on then.
I have a question, teacher.
Yes,
Is it necessary to view my video? Will be. Do you like to see my live picture? Or
no, I want you to have your
it's not
videos
necessary?
off because I'll be using the PowerPoint. There's not enough room to have, so your video, your sound should mostly be off.
Okay. Okay.
Okay.
Thank you. All right.
All right. Okay, any other questions before I go on? Okay. All right, so our tentative plans, and of course the word tentative means they may change. Even today, I'm going to tell you some things that are different. So this is the current plan. We'll have classes live on Zoom. I will record them and post them so that if you miss it or you're not hearing it, you can watch them later, or if you need to review something. If possible, try to be here live because it can be more interactive. It's not very interactive, but you can ask questions. If you're not going to watch it live, then you need to watch the videos in a timely manner. And I actually expect you to watch the videos on Friday, wherever you are. A week later is not okay. You guys, Friday, you don't have any other classes, so it should be no problem for you to watch this each Friday to do this. Okay. And then for the quizzes and the homework, we'll use Rain Classroom to hand those in. I think some of you used those last semesters, others didn't, so you might have to learn a new platform. That's something the school will help you set up and put your name in for that kind of thing. And again, we'll use the WeChat group to post notices and different information. So that's kind of the overall plan. Let me talk about some of the other things. So the material for the class, there's a textbook and the lecture slides and the syllabus. You should already have those. And you should have those available when we have class. For the PowerPoint slides, if you can print those and then take notes, that's probably best. But of course, that's up to you. And then we'll also have some homework answers and quiz answers will be posted on different sites as well. Okay. You need to have access to one of these, not all of them, to get the materials. So I'll put them in the WeChat group. That's probably the easiest. If you can access WeChat, you can just stop there. If you can't or want a different platform, there's the Baidu site and then the Dropbox website. And we'll kind of see if people are not going to use these other two, maybe I'll stop posting information there, especially the Dropbox site. So just a little bit of information about those. Oh, before we do that, make sure when we have class, you always have some paper. Sometimes I'll ask you to do a problem by yourself to practice. So have something to write on, a pencil, and a scientific calculator. Often your phone cannot do the math you need. So make sure you have a scientific calculator and know how to use it. So that's what you'll need for this class. Okay, so the different platforms. Everybody should be in the WeChat group already. If you're not, this is the code, and you need to get in it as soon as possible. And I want you to change your name. A lot of you have names that aren't even your real names. I need to know who you are. So I want you to change your name to the last 3 digits of your student number, and then your first or your last name or both, whatever you'd like to do. So for example, most of you have a student number that looks like this. So you're going to put these last 3 digits. And then for me, I'd put Jean. That's my name, but you put your own name. So that way I know who's in the group and who's talking to me. Okay, so that's very important that you do that. Okay, also the Baidu site, here's the code for that and the website. This is in Chinese, but it's actually not too difficult to use, even if you don't speak Chinese. So if you use this on your computer, it will look like this. And there'll be a folder that says IA International Students. So you just click on the folder. And then when you get in there, there will be different documents. And then if you want to download those documents, so these are the characters for download in Chinese, and you'll find that right there. And that way you can actually download any information. Okay, but again, for most of you, if you can use WeChat, that's maybe easier. If you are outside of China and you can't access WeChat or the Baidu site, I did set up a Dropbox site. This one's harder to use because you have to have a link for each individual document unless you join the group. So if you want to use Dropbox, send me an email to tell me you want to use Dropbox, and then I can give you access to all of the materials. If you are currently in China, you probably cannot use Dropbox. Okay, I think it might be blocked in China. Okay, but anyway, so different options. You need one of those to get materials. Okay, now let's talk a little bit about class participation. This is the point where maybe you're not going to be happy that I'm your teacher, because what you're going to find out is that I take my job very seriously. My job is to teach you and to educate you and to train you to be qualified. And so I'm quite strict with my policies. I expect you to learn the material. If you just think, oh, I'll just watch a few lectures and everybody will pass, that's not true. I expect my students to study hard. I expect them to learn the material. So to do that, you first need, as I already said, to watch all of the lectures. And you need to do this on time. This class has a lot of material. There are 11 chapters in the book, and they just keep coming. So the lectures are going to help you focus on the main points and reinforce your reading. Now, I know it's easy to turn on a video and just play it in the background, and then you can be messing around on your phone and chatting with your friends. And even in this format, I can't see you. You could be going away, but that will not help you learn this class. So when I say active, you need to be paying attention, taking notes, thinking about what I'm saying. Just be involved as much as you can. And again, it's hard in this format. I know that, but this is what it has to be this semester. Okay, so as I said, this is a difficult class. The material is actually not that hard, but there is a lot of it that covers many different topics. And we have to move quickly. This semester, we actually have 2 classes that are holidays. So we're really going to be tight on our time. We may have to have a makeup class. So again, it's really important that you keep up with the work. So I'll just say once again, if you want to pass this class, you must demonstrate that you understand the material. If I have students that fail the test miserably, you get a 30 on the exam or a 40 on the exam, you are not going to pass this class. So you just need to know that right now. You are expected in this class to work hard. And that means you have to spend time, you have to spend effort. Ultimately, you are responsible to learn the material. You know, I can give lectures, I can answer questions, but I am not going to chase you down if you don't do the homework or you aren't watching lectures. That is your decision, okay? Okay, so that's a little bit about my policies and the way things are gonna work. Okay, now having said that, if you do have questions, you need to ask them. I am willing to help you. I'm very strict and I'm very serious as a teacher, but I'm not mean. I'm not trying to fail you. I actually want you to understand and want you to do well. So if you have questions, how do you ask them? Well, if you're attending the live video, you can ask in class. Many of you have already been using the chat box to send messages. So you can send a chat or raise your hand so I know you have a question. You know, and you can either do it by typing or if I ask you, you can turn on your mic and we'll try to ask that way. If you're not live or it's during the week, you can always send me an email or you can use the WeChat group to ask a question. But just be aware that, you know, we're in different time zones, so I won't always answer you right away. You know, sometimes it might be morning for you and I'll be sleeping, depending where you're at. Okay, if you really have something you don't understand and you need some one-on-one, face-to-face, we can arrange a Zoom meeting if we need to. So I am willing to help you, but you have to let me know if you need help. Okay, now let's talk about homework. If you've looked at the book at all, you will see at the end of each chapter are some homework questions. And most of those questions you will not turn in. Some you will turn in to me, but all of them are important. Okay, you need to know how to answer all of the questions. So if there's homework that I need you to turn in to me, that will always be due at the beginning of the next class. Okay, so today there'll be homework, and so you need to turn it in by 8:30 next Friday morning. Okay, and that is for everybody, no matter where you are. Okay, I don't care where you are, your homework is due 8:30 China time the week after homework is assigned. And my policy for homework is if you seriously attempt it and you turn it in on time, you get full credit, even if you do it wrong. I want you to do it. And actually, if you do it wrong, then you learn something. You learn, oh, I don't really understand this. I need to study this some more. So doing the homework wrong will not hurt your grade. It will actually help you study better. Okay, so if you turn it in on time and you do it seriously, full credit. If you don't do it seriously or you don't do all of it or it's late, then you will not get full credit. If you copy homework, you know, if I get 2 homework papers that are the same and they're both making the same mistakes exactly, both papers get a 0. I will not tolerate any kind of copying. And finally, as I said, for this class, there's a lot of material you need to keep current. So if your homework is more than 2 weeks late, I will not accept it. Okay, so you need to keep up with the homework. All right, and then how are you going to turn it in? Usually you will turn your homework in on the RAIN classroom. So most of the time there'll be a homework calculation, and so you'll have to get a piece of paper and you write out your answer. Usually there'll be equations and numbers. And then when you're all finished, you're going to take a picture of your answer with your cell phone, and then you can submit it on the RAIN classroom, and you can access that through WeChat. So the homework has to be handwritten, and when there's calculations, you have to show me the equations and the numbers that you use to get full credit. You can't just give me the answer. Now, actually for today you can, but this is for most homework. And then also on that paper, you need to write your name and student number, okay, so that I know you did that homework because you've written it on your paper. So that will be how we'll handle most of the homework. Okay, and again, you need to make sure you understand all the homework questions in the book. And in fact, I've already given you the answer for most of the questions in the book. Okay, if you don't see an answer, that means you're going to be giving it to me, and then I will give you those answers later in class. Okay, finally, we want to talk a little bit about grading. So for this class, the quizzes and homework and the participation will be 40% of your grade. Now, with this remote teaching, it's kind of hard to do attendance or participation, so that will be a very small part of your grade. But sometimes I might ask you to do something, or to send me something. And actually, right now, I am going to ask you to do that. A lot of you have, when you've signed into the Zoom meeting, you don't have your real name. Some of you do. So I'd like to know exactly who's attending the live lectures. So I actually want everyone right now to open the chat and just send me your name and student number in the chat window. Then I know that you're here live and that you have watched this lecture. So right now, you should send me your name and student number in the chat function for Zoom. So everybody should do that right now. If you're watching this video later, remotely, then you should send me an email and you should tell me, what color shirt am I wearing today for today's class? What color is my shirt? And then I know you watched the video at least to this point. Okay, but for you guys live, all you have to do is send me your name and student number right now. And if you don't, then I think, oh, you're not really watching the video or paying attention. Okay, so, but most of that grade, that participation grade, will actually be homework and quizzes. All right, then the rest of your grade is going to be the final exam, which will be comprehensive. Okay, so the quizzes will, after every 2 or 3 chapters, we'll have a quiz. And that will cover the materials that we talk about in class. It'll be similar to the homework questions. And then we'll use the RAIN platform for that as well. And the quizzes we will always take during class time. They'll be at the beginning of class. So you will actually sign on to RAIN at the beginning of class and take the quiz. For those that are remote, we'll have to work out another time to take the quiz. I need to kind of see where people are and the times, and then we'll decide how to handle that. And then the final exam will be at the end of the semester. That will also probably be on RAIN, and it will be comprehensive, meaning it will cover everything from chapter 1 to chapter 11. So it'll be a lot of material. Okay, so this is kind of the different information, the Zoom code, the Baidu, the WeChat, my email, RAIN classroom, the school will set up for you. You may have to talk to your department about how to get in, or some of you need to link it to the university. And then the Dropbox, if you want to use that, send me an email. Okay, so that's kind of the procedures and the layout of class. So are there any questions about any of that? Any questions there? Okay, and again, you can always
Yes, I
ask
have a
me.
question.
Oh, yes, go ahead.
About the homework submission, you said we should submit at 8:30 the next week after you have assigned the homework. And what I don't understand is, will I be able to submit? Let me say you assign the homework for us today, and then by tomorrow I finish, and then I wanted to submit maybe tomorrow.
Yeah.
So the
Normally, once they get the RAIN classroom set up, you can submit the homework anytime after I posted it, which I will actually need to do that after class. Right now, the RAIN classroom, they did have all of you in it, but now only the environmental students are there and the chemical engineering students have disappeared. So I'm not sure what's going on. So what I'm going to tell you this week is if you're ready to submit the homework and the RAIN is not working for you, then you can send me your homework by email.
Okay, that sounds good. Okay.
Once things are more settled, we'll just try to use RAIN, but in the beginning, we have to be a little flexible.
All right then.
Okay.
That's my question. Yeah. Thank you.
Any other questions? That's a good question. Okay, one other thing before we get into the class information or the class material. I sent this form to the WeChat group and the other places, and I just want to get this information from every student to give me a better idea of the picture. So I'll just go through this quickly. So first, I want you to give me a picture of yourself. You know, you can take it with your phone because I just want to see you guys. You know, I don't see you this way. So I want to see your faces. I want to know what my students look like. So you need to put in a picture of yourself, just, you know, the head. Okay, and then I need your first name and your last name. And I actually have your names from the school, but they give me these long names with your middle name, and some of you have 4 and 5 names, and sometimes the first name and last names are switched, and I don't know which is which. So I want everyone to just give me your first name and your last name, so I know that clearly. Okay, your Chinese name and your student number, that's clear. Then there's a question what I should call you if it's different than your first name. Some of you go by, you know, a nickname or something like that. Okay, so whoops, sorry. Just checking the chat group to see what there was and advance the slide. Too many things to look at. So the rest of the email address, that's clear, you know, your home country, where you are currently, your native language, the language of your high school education. Then I want to know if you think you can attend the live classes, and if not, why not? Now, if you are in China, the answer to that question is yes, you will be at the live classes. There's no reason not to. You know, I know 8:30 in the morning is early, but that's when we meet. So if you're in China, you should be here. If you are somewhere else and there's a bad time difference, then, you know, you don't need to watch live. But let me know what the time is when we have class. Okay, then I just want to know, can you access WeChat? If everyone can access WeChat, well, that will be good. If not, we might have to do something different for some of you. And did you use RAIN last semester? So just yes or no. If you could let me know how you think you'll get the class material, that would help. You know, if nobody's going to do Dropbox, maybe I'll drop that. And then if there's anything else you think I need to know to understand your situation, let me know. Okay, so this form, you can type it on your computer, then send it by email. It should not take you long. And I would like you to do this actually today, if possible. I don't want to wait a week to get all this information. So if everybody could try today to send that form back to me. Okay, yes, somebody raised their hand. There's a question.
Sorry, I want to make 2 statements. The first one is
I'm sorry, I can't hear you.
hear me, Loshi? Hello?
Yes?
Hello? I want to make two statements. The first one is, I cannot take pictures on my phone because I'm using my phone to make the class. My computer is giving problem, so I
Well,
cannot.
you don't need to
use
take a
the
picture
video.
right now. You can do this after class.
Okay, and the second one is I cannot send you an email right now because my email is giving me some problems due to some reason. Is it possible that I can send the things to you on your WeChat?
Yeah, you can send it to the group email, WeChat.
Okay.
But yeah, most people try to use email. I don't want all the forms in WeChat, but yeah, if you can't use email, WeChat is okay. Okay? Okay. All right, so we're now going to talk about just some general things for the class. Most of you should be used to this because you've been studying in China, and many of you come from UK systems. So, but just to be clear, the format of the numbers we'll use for this class, I'm using what we would use in the US or the UK. So we're using the decimal point as a separator, not a comma. Some countries like Germany would use a comma, but we will use a decimal point, or the dot for a decimal point. And then we'll use a comma when we have really big numbers, like 400,000, 456. They don't tend to use this in China, but you will see this if we have a big number, we'll use a comma. So just be aware of the types of numbers we'll be using will be different. Okay, so the next thing I want to talk about should be a review. Actually, most of what I talk about today should be a review, but this is not in your book. But this is something that I care very much about. So when you are doing calculations, you need to pay attention to this. So this is something called significant figures. And the reason I talk about this is because often students ignore this when they're doing calculations, and that's not okay. So what is a significant figure? Okay, well, that word significant means something has meaning, it has value. So these are the numbers that have meaning, that have value. So let's say I want to measure this nail. So how long is that? Okay. And by the way, when we have class, I will often ask you a question, and I want you to answer the question just to yourself. We won't take time for everyone to, type in the answer or speak the answer, but, you should be active. So you should be saying to yourself, okay, how long is this? And so you should be saying that this is about 2.85 centimeters. Now, some of you maybe said 2.84 or 2.86, but everyone should have said 2.8 something centimeters. Okay, so this idea of significant figures. Whenever I measure something, that last digit is always uncertain. Like I said, sometimes somebody might have said 4, or somebody might have said 6. Okay, but all of the digits are significant. So we could ask two questions. Okay, for this number, how many significant digits, how many significant figures are there? Well, all of them are significant. They all have meaning. So this one has 1, 2, 3 significant figures. Okay, how many are certain? Well, only 2. Okay, so we first need to be able to determine how many significant figures does a number have. And you should already know how to do this. I just put these rules here as a review. We're not going to spend a lot of time on it, but just kind of to refresh your memory. Remember that if a number is not 0, it's significant. If you have zeros after the decimal point, okay, like you see for these two, then those zeros are significant. If you have zeros between other numbers, those are significant. So, these are all significant. These are significant. If the zero's a placeholder to the right of the decimal, so like here or here, those are not significant. So we only look at, the last numbers to see what's significant. But remember, this one at the end is significant. And then if you have a number that ends in 0 to the left of the decimal, like these two, 17,000 and 1230, we actually do not know if those are significant or not, because we don't know how the measurement was made. Okay, so those are the quick rules. Let's just practice a little bit. And an easy way to determine significant figures is you just start at the left with the first non-zero digit and you count. Okay, so we've got a bunch of numbers here. Okay, so for this one, how many significant figures? Okay, well, answer's in your notes, but there are 4. Okay, how about this one?
3.
Okay, 3. Okay, how about this one?
3.
Okay, this one is 3. Which 3 are significant? Well, remember, these are not significant. So it's these right here that are significant. Okay, how about this one, the 9.0 centimeters?
2.
Okay, that one's 2. How about 1.0 times 10 to the minus 8?
1, I think.
Okay, well, both of these are significant. So this has 2. Now, what about this minus 8? Is that significant? Well, remember, what does this mean when a number is written with this exponential notation? Well, that means 0.000007 zeros, 1 0. So remember, all of these zeros here are just holding their place. Those are not significant. So the 2 significant ones are these 2 right here. All right, and then this last one, 700 meters. Okay, well, this is that case of the bad notation. I really don't know how many significant figures because I don't know how this measurement was made. So let me show you a little bit what I mean by that. I don't know how it was made. Let's say I want to measure this volume, and I have, different ways to measure the volume. And of course, if I measure it this way, I only would get 2 significant figures. Here, I'd get 3, and here, I would get 4. So the way you make the measurement determines what's significant, or determines how many significant figures you will have. Another example with length. This way, I only get 2 significant figures, but here, 3. Now, when you have non-zero numbers like all of these, then it's obvious how many significant figures. The problem is, when we end in 0. So let's say I have a temperature here, and I want to measure this temperature. What would that number be? Well, if we look at the significant figures, this would actually be 30.00. Okay, so we can actually measure this with 4 significant figures. Now, if you just say, oh, it's 30, well, that means that was done on a different thermometer. Then your marks are either 10 or even 100 apart, depending how you made the measurement. So again, the problem is when it ends in 0, I don't know how the measurement was made. So to avoid this error, we have to use the exponential notation. So going back to that 700. If I write it like this, then I know very clearly how many significant figures. Well, that one has 3. Okay, if I write it like this, then 2. And if I write it like this, then only 1. So anytime a number ends in 0 before the decimal point, you need to use exponential notation. Now, one note about exponential notation, it should always be written with one number in front of the decimal. So this 700, you cannot write it like this, 70.0 times 10 to the first. This is incorrect notation. It needs to be written in one of these formats. Okay, so that's significant figures. Now, the reason I'm talking about this is because we will be doing calculations in this class. This class does have a lab, so I guess those of you in China will be doing the lab, so you will be doing some measuring. But for those of us here in the lecture, we'll just be doing calculations. So we have to know, how do I deal with significant figures in calculations? Okay, and again, you should know this, but I'm just reminding you so that when you do calculations, you pay attention to this. All right, so let's say that I measure something and then I do calculations. So the significant figures in that calculated number is always dependent on the measured numbers. Okay, for example, I have a cube and I measure the side, it's 1.35 centimeter, and I want to calculate volume, which is the side cubed. So I put it in my calculator and I get this number here. So I measured the number, measured the side, and I have how many significant figures? Okay, well, there's 3. And then you put it in your calculator and you give me this number, which has 7 significant figures. Okay, now, do you think it's reasonable that you can measure and have 3 significant figures and then suddenly give me a number with 7? No, that's not reasonable. You know, many of these numbers, they have no value. They're meaningless. Okay, so how many should you give me for the answer? Well, let's look at the rules. So the first rule is for multiplication and division. So for this one, your answer will always have the same number of significant figure as the measured number with the fewest. So going back to this example, if I measure this and I have 3 significant figures, then my answer should have 3 significant figures. So your answer you should give us 2.46 cubic centimeters. Let's look at another example. Let's say I have some water or a liquid and I have 25 cubic centimeters and I weigh it and it's 25.624 grams. And then I want to calculate density, which is grams divided by cubic centimeters. So my calculator gives me this number. Now, what should you give as your final answer? So remember the rule. We look at how many significant figures for this number. Okay, there's 2. How many for this number? There's 5. Okay, so my answer should have, remember it's the number with the fewest, so my answer should have 2. So you should give your answer as 1.0 grams per cubic centimeters. Okay, so that's multiplication and division. All right, then the next rule, this is a different rule, if you're adding and subtracting. Then the rule is the answer is determined by the number with the fewest decimal places. So for example, I want to do a total mass. So what I have to look at is each of these numbers, how many numbers behind this decimal point. Okay, so this first one, 10.21, has 2. The 0.2 has 1. And this one, 0. Okay, so what do I give as my answer? Well, remember, whichever one has the fewest decimal points. So this one has 0, which means my answer should have 0 decimal points. So you should give as your answer 266 grams. Now, this is very hard for you. You say, oh, but I want to just keep a few extra numbers. No, they have no meaning. Because this has no decimal points, it's meaningless to give an answer with decimal points. Okay, so there's multiplication and division is one rule. Addition, subtraction is the second rule. And then there is another rule that's a little bit harder. It's for logarithms. So remember, logarithms are those things where we're raising things to base 10 to a power of x. And there's different ways to represent this. In our class, we will always represent the log as this, log. So remember, the log of 10 to the 5th is 5. The log of 1 is 0. The log of 10 to the minus 2 is minus 2. And then there's also the natural logarithm. That's when you're working with a base e. And again, in this class, we will always use this ln for the natural log. Okay, so, and the natural log of 10 is 2.303. So what do we do for significant figures? Well, this one, you take the number of significant figures in the original number, and then we're going to use that number of digits after the decimal point. So let's look at some examples. Let's say I have this is my original number, 12.8, which has 3 significant figures, and then I take the log. So for significant figures, I'm going to need 3 after this decimal point. Okay, another example. Here's another number. I take the log, and my calculator gives me all of these numbers. So what should I report as my final answer? So remember, what's the rule? We look at the original number, and it has 2 significant figures. So that means I need 2 after the decimal. So you should give your answer as 4.92. Okay, now what about if I have to undo the log, do an inverse log? That might be an example. I have a pH of 4.32 and I want to know hydrogen ion. So that means I need to do 10 to the minus 4.32. So I put that in my calculator. And by the way, you need to make sure you can do this math on your calculators. Take logs and inverse log. You have to do that in this class. Okay, but this is significant figures. So here's what I get from my calculator. Now, how do I deal with significant figures? How many should I have for my answer? Okay, well, remember, this number is a log number. So where is the significant figures? Remember, they are after the decimal. So I have 2 numbers after the decimal, which means that original number had 2 significant figures. So you should give the answer as 4.8 times 10 to the minus 5. Okay, so that one's the hardest one because we have to look at after the decimal. One last thing on numbers, if you need to round, if the number is less than 5, then there's no change. So if I need to round this to 2 significant figures, it's just going to be 1.4. If the number is greater than or equal to 5, we increase by 1. So if I need to round this, that's going to be 1.5. Okay, so that's significant figures. And again, when you do any calculation in this class, you need to pay attention to those significant figures. Okay, we're going to go ahead and stop here and take a break. So we will take a 5-minute break. And then after the break, we will come back and continue. So go ahead and take a break. Okay, did someone have a question? Anything on significant figures? I know somebody raised their hand. Questions on significant figures? Okay, you will get to practice that in your homework. All right, so we're going to go ahead and start chapter 1 now, and just kind of talk about some basic things. Again, most of it I think you should know from other classes. Okay, so this instrumental analysis is actually a very important class. It's an application of chemistry, and it is used in all areas of science. It's actually part of what we call analytical chemistry. And my PhD is in analytical chemistry, so this is my specialty. Okay, now, often I tell people I'm an analytical chemist, and they say, oh, what is that? And I tell them, well, analytical chemistry answers one of two questions, sometimes both. It answers the question, what is this, and how much is there? So an analytical chemist, we determine the composition of samples. And we have a couple of words that we use to describe this. We use the word qualitative analysis, which is what is it? That answers the question, what is it? And quantitative analysis, that answers the question, how much is there? And these are questions we need to answer all the time. Whether you're a chemist or a chemical engineer or an environmental engineer or some other scientist, these are things that you need to do. Analyze, sample, and determine what are they? How much are there? So to give you some examples, qualitative analysis, that answers the question, what is it? So that might answer questions like, oh, what makes the water smell bad? Or how much gold is in a rock? Or is this piece of metal iron or nickel? Or, got a white powder and I want to know, what is this white powder? Those are all qualitative questions. And those are things analytical chemists can answer. Quantitative, that answers the question, how much is there? So, how much lead is in the drinking water? Oh, we hope not much. Hope very, very little. How much gold's in the rock? Oh, I hope a lot. How much nickel's in the steel? That's important for the quality of the steel. How much acetylsalic acid is in aspirin? That's the active ingredients. So all of these kinds of questions will give you actually numbers, concentrations. So if you're doing quantitative analysis, how much is there? There are different concentration ranges we refer to. If it's more than 10%, we call that a major component. If it's 0.1 to 10, it's a minor. If it's 1 part per million to 0.1, that's called a trace component. And then less than 1 part per million is ultra trace. And what we'll see as we look at methods is different methods can measure different concentration ranges. Some of them can do all of these, some only major or minor. Oh, excuse me, sorry. Some methods are special for trace and ultra trace. And now there are also 4 key words that we use when we talk about samples. So you need to make sure that you're familiar with these. The first is the sample. So that's the piece or the portion that we're gonna use to measure that represents the whole. For example, if I want to measure sodium in my blood, I don't need all of my blood, I just get a little tube. That's the sample. The analyte, that's the measured substance. So in my example, that would be the sodium, that's the analyte. The matrix, that's everything else in the sample. So, my blood has lots of things in it besides sodium. So everything besides the sodium, that's called the matrix. And then we talk about the interference. These are things that cause problems in the measurement. For example, if I'm measuring sodium and potassium is present, we know sodium and potassium have similar chemistry, so they might both give us a response. So that could be an interference. If you're trying to measure calcium and you have phosphate present, phosphate will interfere with the measurement, cause problems with your measurement. So 4 key terms that we will be using as we talk about analyzing samples. All right, now the ways that we measure samples, we can take all of the different methods, there are thousands of methods, and we can put them kind of in two categories. The first is what we call classical or wet chemical methods. And you have actually done one kind of wet chemical method. You have done these ones that we call volumetric. So this picture should look familiar to you from the lab, where you did titrations and you used it to determine concentrations of things. Most people don't really like doing this. You have to be so careful and get that exact half drop that causes the color change. But this is a way to determine concentration. There are other wet chemical methods. Another example would be gravimetric. This is where you actually do a reaction and you cause a solid to form, and then you have to collect the solid by filtering it, and then you have to dry it. And this kind of procedure takes hours and hours to do, and you have to be so very, very careful. So these were kind of the first methods we came up with, were these classical methods. Now in this class, we don't care about these methods. We're interested in the other kind of methods. These are the ones that we call instrumental methods. So the instrumental methods, this is where I have some kind of box, and I put my sample in the box, and out comes my answer. Out comes information about what is this? How much is there? So what this class is about is, what is that box? How does it work? What principles are it based on? Of course, it's not magic. I put my sample in and out comes the answer. It's science. So this class is about learning about what is in that box and how it works and how do I use it. So these instruments, they're basically a communication device. So the instrument will convert information about my analyte, information about its physical or chemical properties, into something that I can interpret. And it does this according to the laws of chemistry and physics. So the basic setup is, I have something I want to study. I have something that I want to know. What is it? How much is there? So I'm going to use some kind of energy source that is going to cause my system to give me a response or a signal. Now, what kinds of energy do I use? Well, you can use lots of different kinds. One of the most common is electromagnetic light. You can use light, and that causes your system to do something that I can measure. And then this information I get, okay, this response or the signal, is going to tell me, what is it? How much is there? There are other kinds of energy. We can use electrical energy or mechanical or nuclear or magnetic. And so we're going to be looking at methods. We'll actually just be looking at the first two types of methods, but there are many, many methods out there. So let me give you a specific example. The absorption of light is actually proportional to concentration. So if I have a sample, it's a liquid, and I shine some light through it, some of that light will be absorbed by the sample, and so I will get less light out. And there's actually a law that describes this called Beer's law, and we will talk about this in detail in the next chapter. But basically, the important point here is, notice that the absorption of light, the amount of light absorbed, is proportional to concentration. So this is a method that can answer that question, how much is there? This tells me quantitative analysis, tells me about the concentration. Okay, so that's one of the methods we're going to look at. Now, if you look at your book, you will see there are several tables in your book that give you lots of information about the different methods. So this first table basically is telling me, what kind of energy do I use, and then the names of the methods. So notice this first one, we said it can absorb light, and that can give me information about my sample. We can do many other things: emit light, scatter light, refract light. These are electrical, where the energy is electrical, and they'll give me information. And these ones in bold, those are the ones we're going to discuss in detail. Now, I just want to make clear, these tables, you do not need to learn the information in these tables. They're just there for information. And so I'm telling you they're there, and later, next year, you think, oh, what was that method where we did this? You can go back to the table and, it will help you have information. So for now, I just want you to know these tables are there, but you don't need to learn all this information. Some of it we will learn in later chapters. Some of it we will not talk about in this class. We're actually only going to be talking about 7 different methods, and there are thousands of instrumental methods out there. So it will seem like we're talking about so many things in this class, but we're actually looking at a very small portion. Okay, the other tables have some other information. Oh, okay, I'm getting ahead of myself, sorry. Before we get into the other information, all of the instrumental methods, I just told you there's thousands of instrumental methods. They can be divided into 4 categories. So the first one is this thing that we call spectroscopy. And spectroscopy is the interaction of matter and electromagnetic radiation. And so we will be looking at 2 of these methods, and that will be in chapters 2 through 5 in your book. Then the next kind of method are electrochemistry. These are methods where we transfer electrons. And we'll be looking at 3 of these methods, and that's in chapters 6 and 8 in your book. Then there are some methods that we use to separate. Sometimes I need to separate my analyte from the matrix. And so we'll talk about how we can do that. And so we'll be talking about 2 methods that are called chromatography. So those are the last 3 in your book. And then there are lots of miscellaneous methods that don't really fit into these categories. Okay, so that's kind of where we're going and some of the different methods we will be talking about. Quickly, again, there's these other tables in your book that just give you information. Again, right now, you don't need to learn all these names. A few of these we'll talk about. But notice this table tells me, is a method qualitative or quantitative? So remember, qualitative answers the question, what is it? Quantitative answers the question, how much is there? And then it tells me whether I use the method for elements or molecules. So there's that information. The next table gives you kind of specific information. What kind of qualitative, what kind of quantitative information does it give me? And then the last table has those concentration ranges. It tells me what concentration ranges can I measure, and is the method destructive? Okay, does it destroy your sample? Okay, so again, this is just good general information. You don't need to learn this right now. It's just there for a reference. Okay, let's talk a little bit more about this quantitative analysis. So remember, quantitative analysis answers the question, how much is there? Now, actually, I'm going to stop here, and I hope that you're noting something. How many times have I said, how much is there? What is it? Qualitative analysis, quantitative analysis. It's like, what? I just keep repeating those words and those meanings. And you might think, oh, the teacher is very old and can't remember what she told us. She just keeps telling us the same thing over and over. And actually, compared to most of you guys, I am kind of old, but I am not forgetting what I've told you. I am repeating these things because they are actually very key concepts. So when you're watching the lectures and you hear me repeat something again, and then later again, and then later again, you need to go, oh, this is important. I better know this. So one key, when listening, listen for what I repeat. Those are the really key concepts. So quantitative analysis answers the question, how much is there? Qualitative analysis answers the question, what is it? Okay, so I want to do quantitative analysis, which means I'm going to measure concentration. So I'm going to get some signal or response from my instrument, and that's going to tell me about concentration. So one of the key concepts we need to be able to do this is we have to know how to make something called a calibration curve. So a calibration curve determines what is the relationship between that instrument signal or response and the concentration. And you've probably made calibration curves somewhere in your studies, but the general form for any calibration curve, okay, is always over here's the signal or the response from your instrument, and over here is concentration. That's the general form. Now, remember I talked about that absorbance can tell me about concentration. So notice this curve is that signal, which is absorbance, versus concentration. So how do I make these calibration curves? Well, to make a calibration curve, the first thing you have to do is to prepare a blank. What is a blank? Well, a blank is something that contains everything that your sample has, but no analyte, but everything else. That's called a blank. And then you prepare something called standards. And notice this STD, that's a way to abbreviate standard. So you'll see that in the notes. It means a standard. Now, what is a standard? These are solutions with a known analyte concentration. So you know the concentration of your analyte in these standards. Okay, so you're going to make the blank, which has no analyte, and you're going to make the standards that you know the concentration, and then you're going to measure the signal or the response of the blank and of each standard. And then you make your curve, and then you get an equation for the line. Okay, so notice here, I've got my blank, and notice that the signal response for the blank is 0. And it should be 0 because there's no analyte. Remember, the response, the signal, is from my analyte. But sometimes the response for the blank will not be 0. It should be close to 0, but sometimes it won't be. But here it is. All right, then I have my standards. I know their concentrations. These are their signals, so I make the plot, and I get the equation for the line. Okay, where I know the slope, and I know the intercept. By the way, you guys have been taking classes in China, so in China, the general equation for the line, they, instead of using M for the slope, they use K. But they're the same, just a different letter. Okay, all right, so once you get the calibration curve, then you measure an unknown. So say I had an unknown and its absorbance is 0.3, and I can come over here and determine its concentration from that. Most commonly, you would put it into the equation and calculate it that way. Okay, so calibration curves, very important. Every method except 2 needs these calibration curves. So this is a very important concept. Okay, so just a few minutes into our new course, and already there's several terms you need to know. I think most you've probably seen in other classes, but if any of these are new, make sure you know what all of these are: the sample, the analyte, the matrix, interferences, qualitative and quantitative analysis, response and signal, which basically mean the same thing, the calibration curve, the blank, and the standards. Okay, you need to know all of these different words. Okay, now the last part of chapter 1 actually talks about these 7 different parameters that we use to evaluate a method. So some of the first two, precision and accuracy, you've probably heard of before and know what those are. These other ones maybe are new for you. Okay. So we want to understand what each of these is, because these are important ways that we use to compare methods or determine how good a method is or how bad a method is. Okay, so for today, we're going to just look at these first two, and then we'll get the rest of these next time. All right, so let's start with precision and accuracy. So accuracy is how close you are to the true value. Okay, so how do we know the true value? Well, this is determined from a standard reference material. So this is a compound that or a substance or a solution that you know the concentration. So I buy a sample, it's a standard, and let's say I'm trying to measure sodium. So I buy this standard and they tell me the sodium concentration in this standard is 5 parts per million. Okay. Then I go into the lab and I measure that standard and I get 20 parts per million. Oh, something's wrong with my method or my instrument, because I have a very big difference between the true value and my value. So my accuracy is very poor. So that difference between the true and your measured result, that tells you the error. Okay. So a small error means your accuracy is good. A big error means your accuracy is poor. Okay, so that's accuracy. Okay, precision is how reproducible is your data. So you have to take several different measurements and you see how close together are those measurements. Okay, that's called the precision. So one way to look at these is to think of a bullseye. Okay, so of course we're trying to hit the target. So this first one, they're all close together and they're close to that true value, the center. So this one is accurate and precise. Okay, this one, the average would actually be pretty accurate, but the precision is not very good. The dots are far apart. And theoretically that is possible, but actually this does not really happen in real life. If your precision is bad, your accuracy is going to be bad, almost always. The third example, notice these, the precision is very good, but the accuracy is bad. And in this one, the accuracy is bad, the precision is bad. Okay, now we said for accuracy, we can determine accuracy by measuring the error, okay, the true minus the measured value. How do we determine precision? We can look at it, but how do we actually mathematically determine precision? Well, there are several different ways to do it. By far, the most common is something called standard deviation. The second most common is the relative standard deviation. And you can see, that's the standard deviation divided by the average. So standard deviation is what we will use in this class, and you need to know how to calculate standard deviation. You should have had that in other classes. And in fact, your calculator should be able to do this for you. So I would expect that you can use your calculator to calculate standard deviation. So make sure you know how to do that. Okay, so let's look at some data now. So here I have a sample that's been analyzed by 3 different people, 3 different analysts. And notice they tell us the true value is 10.1. Okay, and notice for each of these, they've calculated the average, and then the absolute error, that's the true value minus the average, the absolute value of that, and then the standard deviation. So thinking about these ideas of accuracy and precision. So for analyst 1, what would you say about the accuracy? Is it good or bad? Okay, well, notice the error is 0, so the accuracy is excellent. Okay, how about the standard deviation? Well, this is a pretty small number. You know, these numbers are close together. So the precision is also good. Now you might think, oh, really, this is not very good. Really, they really should get 10.1, 10.1, 10.1, 10.1, 10.1, 10.1 every time. Okay, if you go into the lab and you give your teacher that kind of data, the teacher will immediately know that you did not do the experiment. You cheated. You cannot always get exactly the same number. There will always be some variation. Okay, so they're never all going to be exactly the same. Nobody is that good. Okay, so that's the first analyst. Good accuracy, good precision. All right, how about number 2? How is the accuracy? Accuracy's not very good. There's a big error. Okay, but the precision, actually not bad. Not as good as 1, but still not bad. So this precision is pretty good. Okay, and then analyst 3, accuracy, not very good. Precision, horrible. This one's a mess. This one's a mess. Now, often our response is to say, oh, analyst 3 is just a bad student. They did a terrible job. But it's not always the analyst's fault. There are lots of things that cause error. Okay, it's not always the person that's the problem. Sometimes it is, but not always. So, what causes error? Okay, remember the error is the difference between the true result and the measured result. So there are 2 kinds of error. One is called a determinate error, and the other one is indeterminate. So notice this word determinate, you can kind of see the word determine in there. So these determinate errors, these are errors that you can identify. You can figure out the problem and you can fix it, usually. Okay, the indeterminate, these are random errors that you cannot avoid. These errors will always be there. So let me give you some examples of what causes these errors. So the determinate errors or systematic, okay, these are caused by the procedure or sometimes the instrument. So it can be any of these kinds of things. The glassware is not calibrated. The instrument's broken. It's not working properly. The chemicals aren't pure. Sometimes it's bad technique or the analyst just did something wrong. It might be a reaction, maybe you're having to react something, A plus B goes to C, and we're trying to measure C, but the reaction doesn't go all the way, so you don't get a good answer. Sometimes it can be the matrix is causing problems. Okay, remember I said earlier, if I'm trying to measure calcium ions, and I've got phosphate in my sample. The phosphate actually causes problems so that your calcium numbers will be too low. Okay. So these are all different kinds of errors. And usually once you figure out what the problem is, you can fix it. You can avoid it. Like this last one. Once I know that this is the problem, there's a way to fix that. And we'll talk about that later. Okay, so that's the determinate errors. So going back to this table of these 3 analysts, where do you think we're seeing a determinant error? Well, we're definitely seeing it with analyst 2. Notice their precision is quite good, but their answers are always too low. Very, very consistent. So there's something going wrong here. It's consistently going wrong. But there's definitely a problem. So we could figure out what that problem is and fix it. When you get all your answers that are always too high or always too low, that's called bias. It's called bias. Okay, so a bias is always going to be a determinate error. Analyst 3 also has a determinate error. Now, these numbers are everywhere, so this one might be harder to figure out, but still there's something going on here that we could figure out. Okay, so that's the determinate or systematic error. Now, the indeterminate error, this is the one that we don't always know what causes it. These are random errors, which means sometimes your measurement is too high, sometimes your measurement is too low. Going back here, here the true value is 10.1. Notice sometimes too high, sometimes too low. Okay, that's an indeterminate error. These are not constant, not a bias. Now, what kinds of things cause an indeterminate error? Well, lots of different things, like limitations in reading an instrument. So let's say that I have a balance. It's going to measure a weight. And this is a balance that only measures 0.01 grams. So what that means, if I have one sample that is 0.12 grams, I'm sorry, this is really messy. It's very hard to write with my mouse. And I have another sample that's 0.107 grams. Okay, the balance is going to give you the same number for these. They're both 0.01. Okay, now these are not the same. There's a little bit difference, which means their signal is going to be different, but that's going to create an error. Sometimes the error is due to electrical noise. As electrons are going through the instrument, they use electricity. Some have more energy, some have less energy, and that can cause changes in the readings. Changes in the environment, if the temperature changes, the pressure changes, if you're using light and the intensity of the light changes with time, these can all cause these indeterminate errors. Okay, now, these errors, they're always going to be there. You can't really correct them. Sometimes we can't even figure out what's causing them. They're just there. Okay, so that's the indeterminate error. Now, because these errors are random, that means they have a random distribution. Like I said, sometimes they're high, sometimes they're low. So, and that's what we're seeing here with analyst 1, is this sometimes high, sometimes low. This is an example of indeterminate error. Now, if you were to take, do we have a way to measure the indeterminate error? Well, if you take a sample and you measure it many, many times, okay, like they did here, they measured it 6 times, you can then make a plot of your measurements, where this is the true value, and you're going to have some that are too high and some that are too low. And it turns out that if you do not have determinate error, okay, if the only error you have is indeterminate error, then the standard deviation is a measure of your indeterminate error. Okay, so going back to that table, right here, this is a measure of the indeterminate error for this analysis. Okay, so that's precision and accuracy, and then the error as that relates to that. Okay, we are going to go ahead and stop there for today. So let me tell you about your homework. So there's several things you need to do. So the first thing, try to send me that student information form. Please do that today, if possible, so I can get the information collected and make sure we have everybody. In the WeChat, when you send that file, change the name to your student number and name. Don't send, everybody sends me a form that says student information, and then it's very hard to find your information later. So change the file name to your student number and name. And you can, just use the last 3 digits is fine for your student number. Okay, so that's the first thing you need to do. Second thing is in the WeChat group. If you haven't joined, you need to do that. And then you need to change your name so that I know who everybody is in the group. Okay, I know you all like your special little display names, but I need your real names. So you're going to write again the last 3 numbers of your student number, number, and then your name in English, please. I don't read that much Chinese, so I don't actually care about your Chinese names very much. Sorry. Okay. So that's the second thing you need to do. Try to do that as soon as possible too, because I'm trying to determine, have I connected with all the students? I need to know if we're missing people. All right, third thing, if you have not read the syllabus, you need to do that. Fourth thing, if you have not got the copy of the book and the PowerPoint, you need to get those, so you're ready to go. Okay, and then finally, from chapter 1, you need to do question 1. So only one question. That's on page 15. And you, if possible, use RAIN to do that. And this question is a significant figure calculations. And right after class, I will go put that on RAIN so you can turn that in. Again, if you're having trouble with RAIN, you can't get in, or you're not there right now, and you want to do your homework early, you can send it to me by email for this time. Okay, for this time only, you only need to give me the answer. Okay, you don't need to show me your math or anything, or you don't need to write the problem. I only need the answers for this homework assignment. And this will be due next Friday at 8:30 a.m. China time. And I don't care if you're in China or not, it's due 8:30 a.m. China time. So if you say, oh, that's the middle of the night for me, then do your homework early, okay? You don't have to wait till the last minute. All right, so on the RAIN, once you get into the system, you have two ways this time to answer it. There'll be a box where you can go in and actually type out your answer. So you can write, A is 77 and B is whatever. And by the way, A is not 77. That is not the right answer. But for this time, you're only giving me numbers so you can type it in the box. Okay, the other way, and this is what we will normally do, you're going to write it on the piece of paper and write your name on the piece of paper, write your student number. That has to be there so that I know you did this work. And then you take the picture with your phone, and then you can submit it on RAIN that way. So one of those two ways. Okay, so that's the homework. Next time we will finish chapter 1, and then we'll probably have a little time to go ahead and start chapter 2. Okay? Okay, so I think that's it for today. So I will, after class, put the homework on RAIN, and then I will also upload the videos. It takes an hour to 2 hours to compile the videos and get them uploaded. So you need to be patient. But again, I will post the videos in the WeChat group, in the Baidu, and Dropbox. Okay, so we'll go ahead and finish the material there. Are there any questions?
Teacher, I have a question about the curve.
About the what? I didn't hear. I'm sorry.
About the curve combination. Actually, teacher, it's
Are you there? Are you there?
you have told like the before the curve there is a slide you have discussed. No, before this.
This one?
Yes.
Okay.
Yes, teacher. No. After that.
Okay.
Yes, teacher.
Okay, so what's
You have
your question?
you have told that we should make a blank, then the standard.
Mm-hmm.
I can't understand. Can you repeat, please?
Okay. So the first thing you do is the blank. And so that's something that contains everything that your sample has, but no analyte. So, let's say you're doing a determination and you have to, add some acid to your sample, and then you have to add some water. So you're basically going to take the acid in the water and that's your blank. Okay, but there's no analyte, there's no sample there. So the concentration of the analyte should be 0 for the blank. Okay? And then you have standards. So standards are one that you know it is. So let's say we're measuring sodium. So we take one standard and we put, 1 part of sodium in it. And then another one we put 2, and then 3, and then 4. So we know the concentrations for those. Okay, and then we're going to take all of those and we're going to measure them. So going back to this, here was my blank and I measured its response, and here the response is actually 0. It should be 0 because there's no analyte. And then these are my other standards, so 0.05, and this is the signal I get, and 0.1 and 0.2. Okay, and then I plot them on a curve where these are the absorbance, these are the concentrations. And then I'm going to get a line, and I'll get an equation. And now, if I have an unknown, I measure its signal, like this one is 0.3. So its concentration would be about 0.15 molar. Does that make sense?
Yes, teacher.
Okay.
Yes, teacher. I can understand.
Okay, good.
Thank
Any
you,
other
teacher.
questions? Any other questions from anyone else? Okay, we will go ahead and stop there so you can sign out and have a good Friday. We'll see you next week. Okay, bye.